Hi, my name is Brandon Dormez, and I'm a sophomore at Dartmouth College. I recently sat down with Calvin Lin, a distinguished professor at the University of Texas, Austin. Professor Lin has done fantastic work into researching computer compilers, architecture, and security. And in addition to that, he also has an interest in computer science education. His Turing Scholars Program, for example, represents a tight knit community of some of UT's most promising CS scholars. And as you will see, that interest also extends down to the high school level. This conversation was a genuine joy to have. Professor Lin talks about what's being done to draw in students from more diverse backgrounds into CS, and he also helps put into focus the creativity and elegance inherent to computer science. I hope you'll enjoy listening to this conversation as much as I enjoyed being a part of it. Thanks. So, the first thing I wanted to know was kind of more biographical. I was wondering if you could tell me how exactly it was that you got interested in computer science.
So that's a good question. I was about your age. I was 4 days before my sophomore year at university, and it occurred to me I had to sign up for my classes. And it also suddenly hit me that whatever I signed up for was basically going to determine my major, or rather, whatever my major was going to fix me on a path, and kind of stuck, right? Because everybody was supposed to graduate in 4 years, and so I went through the course catalog and I tried to look at all the courses I would be taking. So I didn't know what I wanted to do. I thought it might be something technical, physics, engineering, something like that. And so I looked through the course catalog and I read all the descriptions, and they didn't make any sense to me. Like I didn't know what an automata theory was, or compilers, or these various things in physics. So I thought, well, okay, that's not very helpful. And I knew that computer science was not the same thing as programming. But after my freshman year, I thought, well, the course I really liked the most was my Pascal programming course. So even though I know that's not computer science, I'm going to go for computer science. And so really, it was in many ways an ill-informed decision. But the good thing is, the more I took CS courses, the more I loved it. So I think I lucked into this, just what I want to do, and but I have to admit, I think I was somewhat lucky.
Yeah. And yeah, you mentioned something that I think gets conflated a lot, which is programming and computer science.
Right.
So what is the distinction between the two?
Well, programming is a very important tool that we use, and it has a huge role not only in computer science, but in many other fields, right? And so I would say that computer science is the study of computing and of computers and computer applications and those sorts and the uses of computers and computing. But, for example, it can be completely theoretical, right? And in that way, it's very much like math. It can be very applied. There's an engineering aspect to it. There's all sorts. It's such a broad topic now,
Mm-hmm.
and yeah. So for example, right now I do research in computer architecture, and so what are we doing? We're trying to design ways to make hardware faster, more power efficient, et cetera. It's more secure. And yes, we absolutely use programming as a tool to create software simulations of what the hardware that we're trying to study and so forth. But really, we're trying to, the end goal is to design better hardware. Okay? And there are some people who, and in fact, I used to do research in the area of programming languages, where you're really thinking about how do we program and so forth. But again, for many people in machine learning, graphics, and so forth, it's a tool. It's not really, we don't.
So computer science is this much broader.
Yes and no. In fact, but I should also say the other way around. Programming can be used, not applied to computer science, right? You can build apps, you can build websites, you can use programming to do data science. I mean, it has a role in so many. It's just such a powerful tool, right? But I guess another way to look at that is that, we wouldn't say that astronomy is the study of telescopes. Telescopes are a tool right? And without them, we would have a hard time studying astronomy. But astronomy is about more than that, right? It's about the origins of the universe and stars and suns and all those types of things, and it's not about telescopes.
Are there any concepts that you kind of like that you enjoy seeing a lot in CS and seeing how they like map onto other things?
Yeah. Well, let's see. So one thing that's nice about computer science is, to me, a lot of it is just problem solving, right? Mm-hmm. And one aspect of problem solving is dealing with complexity. And one thing that we've managed to do, well, that we do all the time in computer science, is we abstract, right? If you think about what a computer does, it's really incredibly stupid, right? If you ever written a program and you say, do this, do this, do this, you know, it gets, if you don't do it, if you don't say it just right, it messes up, right? Mm-hmm. Whereas if you told your younger brother or sister, hey, here are the directions for how to make a peanut butter sandwich, right? You're probably going to miss some steps, and they'll get it right, okay? Because they're smart, right? Because they'll be like, you know, if you forget to say unscrew the jar, right? Your computer program is like, well, you know, but your sibling is like, oh, I guess I should unscrew the jar, right? Mm-hmm. So on the one hand, computers are incredibly stupid. But what's cool is that, you know, we have things like these amazing apps, right, that tell you how to, I mean, you know, you can just shine your camera and it will, I don't know, there are apps that will give you the French translation of the words that you're looking at and do the fancy things. It'll tell you whether you're looking at, you know, a person or a dog or whatever. I mean, there's just amazing things. And that's all enabled by abstraction, right? Because we're able to program the computers at a higher level of abstraction where we're not dealing so much with this, like the ones and zeros and things like that, right? So, I don't know, that's a simple example of something that, you know, sort of computer scientists deal with all the time. And in some ways, programming is like that too. Programming is a way to encode procedural information, right? How do you do something? Mm-hmm. And that just turns out to be super powerful, right? So I don't know. I mean, that's a great question, and I guess I'm sure there are more. Mm-hmm. But those are maybe two that might top of my head.
I was wondering if you could tell me about how you got into computer science education, through what brought you there.
Yeah. So, you know, I got into being a professor because I wanted to do research, and I also thought I'd like to teach. But when I got to UT here, we started an honors program because we really felt like we weren't really challenging our very best students, right? And so we have this program called the Turing Scholars Program. And I think in many ways, you know, by almost every metric, it's been wildly successful. So we've been very happy with that. But as part of the creation of this program, I started to go to high schools and middle schools to talk about the program and started to interact more and more with, you know, the K-12 pipeline of CS classes. And at some point, I started to see issues. And at one point, this colleague of mine said to me, you know, what are you doing to improve the problem there, right? I mean, if you're seeing problems, what are you doing to fix it? And I was like, wow, I'm not doing anything. And so I started getting interested in this. And around that time, Jan Curie, who was at NSF, National Science Foundation, had a pipe dream of getting 10,000 new CS teachers in the United States, high school CS teachers. Mm-hmm. And she just picked that number out of the air because it sounded really big, and it was a number that was just astronomical by those, you know, just maybe 10 years ago. We thought there's no way we could do that. And now I think she has succeeded. We have, as a community, have succeeded. But that also got a bunch of us to start thinking about, okay, well, if we're going to get a bunch of new CS teachers, what should they be teaching and how should we teach it and all these kind of questions. So that's kind of how I got interested in it. And it turned out, not too surprisingly, we have an excellent College of Education here at UT. And I don't even know exactly how we got involved with them, but as we were responding to this NSF call for proposals, the obvious thing was to partner with people who knew more about education. And so we talked with some folks there, and it turns out our ideas, which were not informed by all the research in education, and their ideas, which are informed by all the research in education, fit in perfectly, and the rest is kind of history. So then we ended up starting this new CS Principles course, which I don't know if your audience knows about that. Should I tell you more about that course? Or
yeah, I'd love to hear it.
So the way I would look at it is, and I don't want to I just a sort of the simplistic view of things, but for a while in the U.S., let's just say 10 years ago, 10, 15 years ago, we would sort of have two classes of high school courses. We have AP courses, which I think are great, but they focus almost exclusively on programming. And worse, they tend to be populated mainly by males and mainly by white and Asian males. Okay? So we have a little bit of a cultural problem there. And in fact, what's interesting, a lot of those teachers of those courses, we equate programming with computer science. So they're not seeing the bigger picture. Okay? At the other extreme, we have, tech app courses, things like, use Word and Photoshop and things like that. And those might not even be taught by anybody with any technical skill, and although they might be, and they're very narrowly focused. And in fact, they're not showing the full, neither one of these types of courses is really showing the full power of what computer science is, right? And in fact, I met students who would say, yeah, I didn't think I liked computer science because I took it, and what they were taking was how to use Word and Photoshop and Excel, and they thought it was just a vocational course, like typing, like, oh, how to use typers, and then they took computer science in college, like, wow, this is great, right? So Jan Curie came with this idea of having what's called a computer science principles course, which kind of fits in the middle. There's going to be some programming, but the whole goal is to show the full power and the beauty of computing and how it can help society and can help mankind and so forth, and how it can have, an artistic and creative aspect to it too. Right? And so that's what this notion is of what's called a computer science principles course, and it is now an AP course. And in some ways, the goal is to be a gateway to attract more students of diverse backgrounds, get them interested in computer science. So then they'll take the next course and the next course, and then maybe major in computer science. And so that was this NSF-funded effort that started 14 years ago or so. And so when we got started, we decided to start our own version of that for the state of Texas. And that's the course that we created here. And one aspect of it is that dual enrollment, which means that students who take it are also at the same time they're taking a high school course and they're getting college credit at the same time. And that has been, dual enrollment courses have been shown to disproportionately benefit those students who are most at risk to going to college. That is, for example, students whose parents have not gone to college and so forth, right? And I think the main point there is that a dual enrollment course makes college much more concrete instead of abstract. It's not like, oh, some weird thing that other people go to. It's like, oh, I took a course and it's not that much different. I mean, it is different, but it's not that much different, not quick, right? So that was one aspect of the course. And the other aspect is it's project driven. And again, there are many studies in the educational field that talk about how the way you really engage students is get them to think about important problems that they care about. It's that to teach the concepts that you need to learn. And so that's what in a nutshell, what our course looks like. And now it's sort of caught on. It's doing pretty well, I think.
Have you personally seen either of your students or anyone else's sort of applying computer science ideas to issues and problems that are outside of the usual scope of CS?
Well, yes. And now I'm not necessarily talking about the high school kids taking these courses, but let's see. So make sure I get this right. So for example, we've had applicants from students to our Turing Scholars Program who've done things like use machine learning to do all sorts of crazy things, right? One is to, and not crazy, but just interesting things. Like one student, actually, this was actually a Turing Scholar, created a tool that looked at Reddit, online, social media postings to predict how individuals would vote in an election. And they actually were able to show that by looking at monitoring various Reddit forums, they could predict, very precisely the polls in the 2016 election, right? Of like, how is Trump and Hillary doing and so forth. So that's just one example. There's this area called formal methods, which is this notion that it's a sort of mathematical area of computer science that says, can we use these formalisms to prove things about software, whether it's correct, whether it's safe, and so forth. Mm. And so there's something called model checking. You don't need to know what the details are, but it's a way to sort of prove and verify things. So one of our students, as his honors thesis, took one of these virtual worlds called Second Life, which I don't think is big anymore, but I don't know what's big anymore these days. And he used it and he used formal methods to help these anonymous, agents agree to contracts and prove things about, what they were doing, because you really don't know anything about the other person, right? So like, I can't go into the details, that would take a lot of time, but it's, again, applying computer science ideas. Mm-hmm. In this case, he was interested in this virtual world and how people interact in them in a sort of a trustworthy manner, and that's what he applied it to. Let's see. Other interesting. Well, yeah, here's one. So obviously, traffic's a big problem.
Yeah.
One of our graduates right now is he went off and worked at Google, but he's quit now, and because he's pursuing his passion, he's trying to create ways to have smarter cities. And he's not the only one doing this, right? And there's so many ways to look at this, right? How one is traffic patterns and so forth. And but anyways, if you think about it, in fact, one of the things he did when he was in here for his research was he showed how if every car was self-driving, that we wouldn't have to have stoplights, because at intersections they would be smart enough they would slow down a little bit, but they would keep going instead of all sort of synchronizing. Everybody stop, and so there's really neat simulations of all the cars. Like, it looks like they're crashed, but they don't. They just kind of make small adjustments and they keep going through the intersection. Now, obviously, if you're a pedestrian, you have to cross, so that's not good news. but think about it, things like that could make a huge difference, not only for our quality of life, but for reducing all the energy that we waste at stoplights and stuff like that, right? So my point is that there are just lots of examples of people applying, computer science to things that you wouldn't expect them to. Oh, here's another example. So there's a student at UT who's doing research in machine learning with a professor in the classics department. The professor studies ancient Greek poetry, and the professor can tell the difference between ancient Greek prose and ancient Greek poetry, but he's working with the student to see if the professor can tell the difference between ancient Greek prose and versus ancient Greek poetry, but he can't tell you why. He can look at it and say, well, I know why. So he's hoping that by framing this as a machine learning problem, the machine learning algorithm can learn the difference, and then using that, he might be able to get some insights as to what was it that it used to figure out why it works, right? So this is being applied to humanities, right?
The student who was interested in smart cities, do they have a company now?
No, well, right now I believe he's working on his own. Mm-hmm. And so, whenever you get to the real world, there's this question, right? He could have worked with Google. Google has some efforts in smart cities, and that on the one hand would give him great resources, right? And cachet, like, oh, I'm Google. Mm-hmm. And he felt it might be too constrained in terms of what he wanted to do. So he decided to strike out on his own. And so now, he's as he's sort of, wandered the country, he's found like-minded people who are doing similar things. And at some point, he's going to have to either, to make a difference, yeah, he'll have to either contract with the city or create a company or join a company or something, right? I guess he's got enough money now that he can he can get by just sort of working on his own.
Do you have any sort of ideas or comments you wanted to touch on, but we didn't get a chance to?
Well, let's see. If we're talking to young students who don't know what they want to do, one message I have is to try not to let stereotypes, cultural stereotypes, affect you too much, right? If you watch TV shows, there's the private investigator or the lawyer or the business people, and they look like models, right? They're attractive and they dress nicely and so forth. And then there's the computer geek who is socially unacceptable or whatnot, and a geeky person. And I think that has, that's not, we have people of all types, right? And that's not a good image or even an accurate image, right? Mm-hmm. So maybe an image that if you become a programmer, all you do is you sit in a cubicle all day and you never talk to anybody and you're not actually a sociable person. And I think that's also wrong. I think so much of computer science and programming is collaborative, right? And what's interesting is it's mostly the tech companies that are experimenting with, different floor plans and open offices and, different ways to engage people. So I think this notion that it's a solitary confinement it can be if you really want to, almost anything can be, but it's often sociable. And I think the final thing I would say is that you often hear young kids say, well, I want to be a doctor, I want to be a veterinarian because I want to help people, I want to help animals. And that's great. Those are great, worthy things to do. But if you want to help humans and help humanity and make a difference, oftentimes there's no better way to do it than with the power of computers. So maybe learning something about computer science or even majoring in computer science could be a great way to make some of these changes. So, for example, right now, we were interviewing somebody for a faculty position here who is trying to bring computer networks to many of the third world countries where they don't have the infrastructure, to have these things. And they're super clever as to how you can harvest, all sorts of latent energy sources to do computing and to bring, networks to folks who are underserved. And I can't imagine something more powerful or enabling than giving people access to the internet who don't have access, right? So that's my point. My thing is my I guess message would be is keep an open mind. It's an amazing field that is exciting, that's having impact, that's like I said, it's at every point in time you can say, wow, this is such a great time to be studying computer science, and it's hard to see that stopping. So, not to mention there are lots of jobs, but you should do it not just for the jobs.
All right. Well, thank you so much.
Great.
Yeah.
You're welcome. And if you have more questions, let me know. I'd be happy to talk again. So, right, good luck.
Hi, this is Brandon Dormes again, and we just wanted to say thank you for joining us. And if you would be so kind, please click the subscribe and like buttons. We hope to see you again next time. Thanks.